Hey guys, welcome back. Today we're going to be doing the following the following two exercises with their subparts. Pause the video now if you want to try, and come back for the solution. All right. So for the first one, I like to always draw out things. H2 CH2 CH CH2 CH3, and then CH2 CH2 BR. So the first thing I want to do is first locate the longest carbon chain and denote how long it is. So it would be 1, 2, 3, 4, 5, 6 carbons long. So 6C, which means our name would end in hexane. And the best way to go about organic naming is to actually work backward. So, alright, now we want to locate the highest order functional group, which would be bromine, this halogen here, since it has more reactivity than any hydrocarbon part. So, and that halogen is attached to, if we call this carbon number 1, it would be number 6. But since we know that the highest order functional group gets the lowest number, we have to name from this side. So it would be 1 bromohexane. 1 bromohexane. So let me just move this a little bit closer such that it actually looks like what I'm talking about. 1 bromohexane. And then lastly, I want to look for any branches. So there's a branch, and it is 2 carbons long, so it would be an ethyl, and it is on carbon 1, 2, 3. So we would put a 3 there. And then now that we've got sort of the puzzle pieces of our name, let's name. Let's complete the formalities. Now, typically, when you list off branches, you separate them by commas, except for the last branch, which you affix onto the name, and then if it's between a name and a word, you put a dash there. So the name would be 3-ethyl 1-bromohexane, and that dash shouldn't be there, but that would be the name of this compound. To summarize what we did, first we located the longest carbon chain, then we tried to locate the highest order functional group, and then we numbered everything relative to that being, we gave that the lowest number, and then we looked for other branches and then located them based off the fact that we know where the highest order functional group is, and we can count our carbons from that. Alright, for the next one, let me select all, delete. For the next one, we have, can I get a pen? CH3, CH2, CO, C double O, and then we would have CH2, CH2, CH3. Now this is an ester, and ester naming is a little bit different. The carbon that is attached to both oxygens, the branch, is considered the highest order functional group. It's considered a carbonyl group, and this carbonyl group is attached to this chain here. So this gets the ending here, which would be, since this is 1, 2, 3, 4, 5, pentanoate. So this would be pentanoate. And then this is 1, 2, 3. So this would be propyl pentanoate. Since this is 3 carbons long, this is 5 carbons long. 1, 2, 3, 1, 2, 3, 4, 5. And this should really be 1, but it was just to demonstrate a point. So that's how you name esters. It's only esters that have this weird naming convention, and again, it comes from the condensation reaction of this being the old carboxylic acid, this being the old alcohol, that sort of convention. So we name it according to that. For the last one we have to name here, we get CH3, CH2, CH2, CH, CH3, and then C double bonded to an O, bonded to an H. Now, it's important to note that despite the way I wrote it, it could be an alcohol. It could theoretically, it looks like an alcohol, but the only way for carbon to obey the octet rule is if that oxygen is double bonded. So be careful. And typically the way we denote that in organic chemistry is we write CHO rather than COH. OH indicates alcohol. HO generally indicates aldehyde or ketone, depending on where it is. So like always, first we locate the longest carbon chain. It would be 1, 2, 3, 4, 5. So this is a pent. And now, since this is a an aldehyde functional group, so pentanal, and then on carbon number 2, we notice this methyl branch, so it would be 2-methyl pentanal. 2-methyl pentanal. All right, perfect. So here's our second question. Draw a structural formula for the following: 3-ethyl 2,2-dimethyl pentanoic acid, 3,4-dimethyl heptan 2-one, and C would be ethoxypentane. Pause the video if you want to try, and come back for the solution. All right. Presumably you're back. Now, let's use the fact that we know that generally organic naming tends to go backward. You generally tend to name it from back to front. So first you locate the longest carbon chain, then you branch. You name it backward to the way you read it. So let's take advantage of that fact and sort of start backwards. So we know this is pentanoic acid. So we know the main carbon chain is 5 long. So 1, 2, 3, 4, 5, and then I know that there is a O and an OH. I know that that is COOH, since we are told that is a carboxylic acid. Since we are told that is a since we are told that it's pentanoic acid. And then since we know where carbon number 1 is, this one is carbon number 1, since it has the acid part of it, we can sort of work our way backwards. So this would be H, and we are told that there is 2,2-dimethyl. So let's sort of COOH. And since we are told that there's 2 methyl groups here, let's draw those 2 methyl groups here. And then we are told on the third carbon there's an ethyl group, CH2, CH3, H, H2, H3. So that is the structural formula for the following, for 3-ethyl 2,2-dimethyl pentanoic acid. And if you want to check, you can name your compound, and if it matches the name you were given, then it's correct. For the second one, we have 3,4-dimethyl heptan 2-one. So we have a ketone, and we know that the carbon chain is 7 long. So 1, 2, 3, 4, 5, 6, 7. And we know that there's a ketone on the carbon number 2. And it doesn't matter where I put this double bonded O. I could have easily just as put it here, but I'm just going to put it here, and we'll call that carbon 2. You couldn't put it here because then it wouldn't be 2, but if you counted from here 1, this could be 2, or if we call this 1, we could count that as 2. And then we are told on the third and fourth carbon, there are methyl groups. So there are methyl groups, CH3, CH3. That should be on that one there. And then we put then we fill in our hydrogens. So so that one couldn't go there. So now we can sort of simplify things a little bit. So that one's fine. That one needs an H. That one needs an H. This one needs an H. This one needs two H's, two H's, and then three H's. So let's write this out a little bit cleaner. H3, H2, CH2, CH, CH, CH3, CH3, C, CH3, and then double bond that O there. And that's our answer. For the last one, which is we are given ethoxypentane, and we know that there is a 5-carbon long chain, so C, 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 H3, H2, 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 and note that this is H2 because there is a alkoxy branch coming off of this, so this would be, so we would put an O here, and then CH3, CH2, and that's our answer. And the way I did that, I knew that our longest carbon chain was 5, so 1, 2, 3, 4, 5. Or, no, rather, we should name it from here because this is the highest order functional group. 1, 2, 3, 2, 3, 4, 5. And then I put an ethoxy branch since this is 2 carbons long, and then the oxy indicates the oxygen, so a oxygen branch with 2 carbons attached to it, and then the main chain is 5 carbons long, is sort of what the name implies. And that's our answer. I feel like I may have rushed this video. I don't know. If you want some more examples, if you want some more video examples, please let me know in the description. Don't forget to do the typical user versus stuff. Thank you for watching.